Hello everyone, and welcome to today's video on classifying numbers as rational or irrational. So in 7th grade we talked about classifying numbers and looking at different types of rational numbers. We just kind of glossed over the idea of an irrational number. So we're now officially defining irrational numbers. So irrational numbers are numbers that cannot be written as a ratio of integers. And the definition of a rational number, most exactly, is a number that can be written as a ratio, rational, of integers. Okay, we know integers are numbers without decimals, right? So they're whole numbers, positive and negative whole numbers. So like negative 10, 10, 7, 0, 5, all of those are integers. So any number that can be written as a ratio of integers is rational, and any number that cannot be is irrational. In decimal form, irrational numbers look like numbers that go on forever. The decimal goes on forever, so it does not end, does not terminate or end, and it doesn't repeat. So we don't have like 0.3 repeating. So they go on forever with no repeating pattern. Up to this point, the only irrational number we've really talked about is pi. So pi is an irrational number, 3.141592, goes on forever without having any repeating pattern. That's irrational. But it's not the only irrational number. There actually are infinitely many irrational numbers, including the square root of any non-perfect square. So we know at this point that the square root of 4 is 2, because 2 times 2 is 4. The square root of 36 is 6, because 6 times 6 is 36. So there, when we are taking the square root, we get rational numbers because we just get a whole number, a natural number, 2, 6. Those are very much rational. However, if we take a perfect square of a different number, like the square root of 2, we get an irrational number. If you look at it in the fraction form, it's a number that goes on forever with no repeating power and no end. It's about 1.41421356, ... right? There's no pattern there. It's not going to stop. And that's going to be the case for the square root of any number that's not a perfect square. Okay, so we're just adding to our collection of irrational numbers. And there are other irrational numbers. These are just ones that have significant importance. So today in this video, we're going to look at some examples where we're asked to classify numbers as rational or irrational, or apply the concept. So here's kind of a definition one that's interesting. We're asked which statement describes values of x and y such that x divided by y could be an irrational number. So we're just going to go through each of the 4 multiple choice question options. The first one is the value of x is 0 and the value of y is an integer less than 0. So I have A thinking about x, y, and they're telling me that x is 0 and then y is an integer less than 0. For example, like -3. Okay, so this cannot be irrational because what's 0 divided by anything? 0 divided by anything is 0. The only exception is 0, which we don't worry about. So 0 divided by anything is 0, okay? And what type of number is 0? It's very much a rational number. It's a whole number, so it's an integer, so it's a rational number. Okay, so that cannot be it, so A is out. B says the value of x is the square root of an integer, and the value of y is a positive integer, an integer greater than 0. Okay, so taking a look at this, I see my square root symbol. So that's promising, right? If we take the square number of some integers, we do get irrational numbers, right? Like, for example, the square root of 2 is irrational, and then we could just divide that by the number 1. That's just equal to the square root of 2. And what did we say? Well, we said that the square root of 2 was an irrational number. So B is correct. B is a situation where we have the square root of an integer that we're going to get an irrational number. But let's take a look at the other 2 options quickly, just so we can see why those are always going to give us rational numbers. In C, we have x is an integer less than 0, and then y is an integer greater than 0. So you just have a positive integer, or a negative integer divided by a positive integer. Ultimately, that's going to be a ratio or a fraction of integers. Thus, it'll be rational no matter what, because that's the definition of a rational number. And for the last one, we also have the square root. We see that the value of x is a square root, but then it says that can be simplified to an integer, such as 16. The square root of 16 is 4. So they're saying that we're taking the square root of a perfect square. So we just get an integer ultimately. It's simplified to an integer divided by an integer. And again, when we have a fraction of integers, that's rational. Cool. All right, let's see a few more examples. Here in example 2, they're saying which number is positive, rational, and has a value between 0 and 1. Okay, so what I'm going to do is let's go through all of these numbers. We'll create a little table. So we need, our right answer is going to be positive, rational, and be between 0 and 1. Okay, so first one is negative 0.2 repeating. First of all, is negative 0.2 repeating positive? No. Okay. So is that positive? No. So already we can eliminate A. But for what it's worth, is it between 0 and 1? Well, its absolute value is between 0 and 1, but it's negative, so it's not between 0 and 1. It is a rational number, though, okay, because this is an important concept to remember. Whenever we have a repeating decimal, 0.2 repeating, negative 0.2 repeating, that is going to be rational. You can write that as a fraction. That happens to be equivalent to negative 2/9. Okay, but still, it needs to be all three of these, so that's out. All right, then I have pi minus 3. Interesting. Okay, so pi is about 3.14. So we have 3.14 minus 3. Is that going to be positive? What's about 3.14 minus 3? Yeah, this is going to be about 0.14. So the answer, it will be positive, and it will be between 0 and 1. But this is not going to be rational, because you're taking pi, which is irrational, and then you're subtracting away 3. So then you just get 0.14159265355, and it's going to go on forever. Okay, so this one is irrational in B. All right, then C, I have the square root, so we might think, all right, that's a good sign that it's going to be irrational, but it's not necessarily. So let's take a look. The square root of 1/4. So this is one, if we have to, we can pull out a calculator and figure out what this is. But the square root of 1/4 is saying what number times itself equals 1/4. And there is actually a pretty simple answer to this. 1/2 times 1/2 is equal to 1/4. So the square root of 1/4 is just 1/2, or 0.5. Okay, so is 1/2 positive? Yes. Is 1/2 rational? Yes. And is 1/2 between 0 and 1? Yes, exactly between 0 and 1. Woo! Okay, so C is our answer then. And if we take a look at D, we have 3/2. That is positive and rational, but it is not between 0 and 1. All right, let's look at 2 more examples. So now we have a number is shown below, 0.56 repeating. Right, so this number is like 0.56565656, and that's going on forever. So which of these statements is true? So let's first address this point. Is this number rational or is it irrational? So what did we say about numbers with repeating patterns? whenever we have a repeating decimal that is rational. Yep, so this is going to be rational. And then we're trying to figure out what fraction this is equivalent to. So we haven't done a ton with this. You could figure this out in a calculator. You could do 56 divided by 99 and see if that gives you 0.56 repeating. And then do the same thing with 56 divided by 100. But process of elimination will help us figure this out as well. So this is not irrational. It's rational. And then 55 hundredths, that's equal to 0.56. Just 0.56. Right, there's 56 hundredths. This is 56 hundredths. So this is just 0.56. But when you have 56 99ths, yeah, that is where we get these repeating situations. That is 0.56 repeating. So the answer to this one is going to be A. And we just have to remember that when we have a repeating decimal, that is rational. And it's rational because it can be written as a ratio of integers. In this case, 56 99ths. All right. And then lastly, we're asked which number is irrational. So we have some integer, 3, 9, 4, 9, and then we're multiplying by some square root. So if you have an integer, you multiply by another integer, you're going to get another integer, it's going to be rational. We're going to get an irrational if one of these square roots is irrational. Once you take an irrational number, you're multiplying by a rational number, you're still going to get an irrational number. So we just have to figure out which of these square roots is going to give us an irrational number. All right, so first we have the square root of 9. What is the square root of 9? 3. Yeah, square root of 9 is 3. So 3 times the square root of 9 is just 3 times 3. So that's just 9, which is rational. All right, then we have 9 times the square root of 3. So is 3 a perfect square? If we take the square root of 3, are we going to get a rational number? No, 3 isn't a perfect square. So if we take the square root of 3, we're going to get this long fraction, or long decimal, 3 times 1.7320508, and that goes on forever. Okay, so that will be irrational. Here we have the square root of 9. Again, that is 3, so we get 4 times 3 is 12, which is rational. And the square root of 4 is 2, so we get 9 times 2, which is 18, so again, that is rational. We just need to look for those square roots of numbers that are not perfect squares. That's when we're going to get an irrational number. All right, that's all it is. Just some good practice identifying, understanding, and classifying rational versus irrational numbers. Great job, everyone.